Is current engineering not reaching modern scientific complexity, or scientific complexity has not yet found parameters in current engineering? This is a Edilson Gomes de Lima reflection on the current galloping progress of the sciences versus the apparent stagnation of engineering. The modern science progress and engineering has not been on the same level as before, to which we see the current stagnant engineering repeating old procedures, and within precise and specific scopes. However, in recent decades, we have witnessed a monumental progress in the sciences at the level of not being reached by the current progress, which here we can call technologies by engineering, especially mechanical engineering. In the world of science, both disciplines follow patterns of exponential complexity, and in recent years we have seen the sciences rise a lot in their exponential progress, and in many cases leaving their attributions and even invading or using attributions from other sciences due to the increase in complexity. Something normal and that tends to expand from now on. The traditional sciences every day will tend to be no longer homogeneous, but more and more heterogeneous. As in a machine in mechanical engineering, it is easy to say that in a complex machine there is engineering, but overall, there are hundreds of parts and complexities of the various sciences involved, from mathematical geometry to a simple lever to even some vital chemical mixing process. Operation, or even more complex processes involving hundreds of joint operations. This expansion of complexity from now on will be part of companies as competitive and prominent factors in the market. There is no way to enter the market today only with the issue of quality. This factor is gone in the 90s, from now on it will be a matter of complexity and technological expansion to levels almost unattainable for most companies. All due to the accumulation of complexity that has been increasing exponentially in science in recent decades. Clearly observed by the crossing of the exponential curves of advancement of each science and their interpolations between different sciences. But nothing could better describe the present time than again the paradoxes and paradigms that will be presented throughout this series and this scientific sequence. We really live in a different phase of human history, which paradoxes in engineering and science will tend to confuse and explain. Given this, we do not want to enter into philosophical fields, but seek in this understanding a more popular understanding of the size paradigm to which the sciences are taking us. Understand the paradox as a statement that is true but leads to a logical contradiction. Or it leads to a condition that contradicts commonly accepted intuition. Therefore, the paradox is the opposite of what is thought to be the truth. And nothing better could describe the current science that is heading towards high complexity and even dystopian scenarios. Seen the new phases of cutting-edge frontier in physics, particle science and the resulting technologies absorbing immense complexities. And this truly dystopian series intends to bring reflection from the point of view of sciences, engineering and nanotechnologies for the paradoxes involved.